So in this series we are going to be dealing with sequences. So what's a sequence? So a sequence is just an ordered list of numbers. For example, like 1, 2, 3, 4, 5. This is an ordered list of numbers. This is not just any list of numbers, but it's ordered. Why? We can see that there's a pattern with these numbers. So 1, 2, 3, 4, 5, you can see that we are adding 1 in every consecutive term. Okay, so that's a sequence, just an ordered list of numbers. Okay, but then we have a type of sequence which we call an arithmetic sequence. So an arithmetic sequence is still a list of numbers with a pattern, ordered list of numbers with a pattern, but now they have a constant difference. For example, let's go back to these numbers I wrote before, which is 1, 2, 3, 4. So you can feel the sequence, you can feel the progression of these numbers, that we are going to have 5 and 6. So this is a sequence where the constant difference of these terms is 1. So this is the number that we are adding every time that we are counting these sequences. We also have other types of sequences which are arithmetic, like 2, 4, 6, 8, 10. This is still an arithmetic sequence because we have an ordered list of numbers, and that order list of numbers has a constant difference, which in this case is going to be 2. You can see that we are adding 2 every time, we are adding 2 every time, we are adding 2 every time. So you can see that we are going to have 12 and we are going to have 14 and all those things. So you can see this is just an arithmetic sequence. Okay, now there are a few things that we can pick up from this. So whenever we have a sequence or an arithmetic sequence, to be specific, there are 2 things that we can get from that sequence. Number 1, we can get the first term of the sequence. Like in this sequence, 2, 4, 6, 8, 10. We can get the first term of the sequence, which is going to be 2. So we can see that 2 is our first term of the sequence. We usually call it T1. It's term number 1. And then what we can also get from this is the difference between the numbers. We can see that the difference between these numbers is constant and it's 2. Therefore 2 is going to be our difference. Okay, now we have 2 things. So we have A, which is going to be 2, and we have D, which is going to be 2. So A is equal to 2 is from the first term, and then D equal to 2 is from the constant difference. But we can also have other types of arithmetic sequence whereby we have 10, 8, 6 and 4 and 2. So you can see also this is arithmetic, since we are adding -2 from 10 to get 8, and then we also add -8 to get 6 and so on. So you can see this is a sequence of numbers. It's an ordered list of numbers. So we have that A is equal to 10. This is the first term of the sequence, and then we have D, which is going to be -2 in this case. So this is just the generic stuff that you need to pick up when you're dealing with an arithmetic sequence. There is a first term and there is a constant difference. Alright, so now let's look at this question. So let's take 3, 7 and 11 and 15. Now from this sequence we can pick up certain things which are very important. Number 1, what is the first term of this sequence? Okay, the first term is 3, obviously. Okay, so the first term is 3. We can write T1, which is equal to A is equal to 3. So A is just a symbol of the first term. You're going to see why are we using A as we continue. Okay, now what is our difference from this pattern or sequence? Okay, so the difference is going to be 4. You can see that I added 4 from 3 to get 7. So I add 4, I add 4, I add 4. So the constant difference, just take that aside. The constant difference is 4 4, 4. Okay, so D is equal to 4. Right? So those are the important things that I need to try to extract from the arithmetic sequence. It is the first term and what is the difference between the numbers. Okay, so that is very important. Okay, so now that I have these two numbers which I've picked up from the sequence, which is the first term and the difference, I might want to know what will happen to the fifth term, sixth term, or what would be the value, to be specific. So as we can see here, we have that T1 is equal to 3, okay, that T2 is equal to 7, that T3, okay, term number 3 is going to be 11, then term number 4 is going to be 15. What is term number 5? So what is going to be term number 5? So term number 5 is going to be 19. How did we get 19? We just added 4 from 15 to get 19. So okay, you can continue and want to get what is going to be term number 6. Okay, and then you're just going to add 4 again to 19 to get 23. All right, but then what if you want to know what is term number 102? Okay, let's say you want to know what is term number 102. So as you can see, that's going to take a lot of time trying to add these numbers up until you get to 102. We obviously need a formula to solve this. Okay, so what is the formula? So we know that an arithmetic sequence has a general formula, and the general formula is going to be Tn equals to A. Now no, A is the first term plus n minus 1 D. Okay, we have to explain what are these. So Tn is the nth term, which means when we have numbers like 1, 2, 3, 4 up to n, so n represents the position we don't know, because we know this is the first position, second, third and fourth, but n is the position we don't know. Like for the previous example, we can see that n in this case is 102. So we know that we want the 102nd position. Okay, so we know that that's going to be our n. So n in this case is just 102. But now here, n is just a variable that represents all those numbers. Any number could be n. Okay, so we are generalizing. That's why this is called a general formula. We are generalizing. We don't want to be specific and say we want the 10th term, or we're just generalizing everything. So this is going to be the nth term of the sequence. Okay, so this is going to be the nth position, and then Tn is the term at the nth position. So the value of the term at the nth position. So Tn is the value of the term at the nth position, and then A, as we know, is just going to be our first term, and then D is going to be our difference. So, and then D is going to be our difference. Okay, so for this question, we therefore see that we can just use our formula and then get the answer, what is going to be T102. So let's just punch it in the calculator and say, okay, now T102 is going to be, what is our first term? Our first term was 3, yes, plus, and then we know that this is going to be 102, that's our n, and then minus 1 multiplied by D, what is our difference? That's going to be 4. Okay, yes, that's going to be 4. Okay, now to get the answer to this, we just need to use our calculator. So we can going to bring up our calculator and then punch that expression into our calculator. So this is going to be 3 plus 102 minus 1 times 4, and that is going to be 407. Okay, this is going to be 407. So T102, the term, the value of the term at the 102nd position is going to be 407. So what does this mean? It means that since my sequence was 3, 7, 11 and 15, I'm going to go up to, so this is the first term, okay, first, second, and then third, and then fourth. So at the 102nd position, I'm going to have a value which is going to be 407. So that's what it means. The first term is 3, the second is 7, the third is 11, the fourth is 15, and the value of the term at 102 is going to be 407. Okay, now we can find a lot of values like T23. You can get T23 and you can get T22, T55, any value using the formula. So that's the importance of using the formula, is to try to get to numbers that are going to take time when you're trying to calculate by hand by just plugging in on the formula.